One circle and 17 theorems. Let's try to understand each one by one with example. But before we begin, let's first understand some basic terminology related to a circle. This is the center of the circle. All points on the circle are at the same distance from this central point, and it is usually labeled with a capital letter O. If we draw a line from the center to any point on the circle, it is called the radius. It is usually labeled with a capital letter R. The radius is the same for all points on the circle. Now, if we extend this straight line across the entire circle, passing through the center like that, we get the diameter. This is usually labeled with a capital letter D. The diameter is always twice the length of the radius, no matter how big or small the circle is. A chord is a line segment connecting any 2 points on the circle like this, not necessarily passing through the center. This one usually labeled as letter CH. Now here's a quick question for you. Can you tell me which is the longest chord of a circle? Drop your answer in the comments below. Moving on to next part, any curved part of the circle between 2 points just like this is called an arc. This curved section is typically labeled as ARC. A sector is the area enclosed between 2 radii in the arc that lies between them like this. You can think of it as a slice of pizza pie. When a chord divides a circle into 2 parts, each part is called a segment, and there are 2 types of segments in a circle: the major segment and the minor segment. The major segment is the larger portion and usually contains the center of the circle like this, whereas the minor segment is the smaller part and does not include the center. The circumference is the total length around the circle. It is also known as the perimeter of the circle. A tangent is a straight line that touches the circle at exactly 1 point and does not enter the interior of the circle. On the other hand, secant is a straight line that cuts through the circle, intersecting it at exactly 2 points like this. Now let's talk about an important term related to angles. When an arc or chord creates an angle at a point, we say the angle is subtended. If the angle is formed at the edge of the circle like this, we say it is subtended at the circumference, whereas if it is formed at the center of the circle like this, we say it is subtended at the center. Now that we've covered all the basic terminology related to the circle, let's explore each theorem one by one, breaking them down in a way that's simple, clear, and easy to remember. 1. Angle at the center theorem. This theorem states that angle formed at the center of a circle is always twice the angle formed at the circumference from the same arc. That means if this angle at the circumference is 40 degrees, then this angle at the center is 2 times 40, which is 80 degrees. 2. Angle in a semicircle theorem. This theorem states that any angle formed in a semicircle opposite to the diameter of a circle is always a right angle, or 90 degrees, and diameter of circle is hypotenuse of that triangle. So if AB is the diameter and C is any point on the circle, then this angle ACB is 90 degrees, and side AB becomes the hypotenuse of the triangle. Now here's a quick challenge. If one side of the triangle is 6 units and the other is 8 units like this, can you figure out the length of the diameter? Try using the Pythagorean theorem and let me know your answer in the comments below. 3. Angles subtended by the same arc theorem. This theorem states that angles formed on the same side of the same chord are always equal. For example, here this angle, ACB, and this angle ADB are formed using the same chord, AB. That means angle ACB is equal to angle ADB. 4. Alternate segment theorem. This theorem states that the angle between a tangent and a chord drawn at the point of contact is equal to the angle in the opposite segment of the circle. For example, when tangent and chord AB drawn from a point A like this, then this angle between the tangent and chord AB is equal to this angle formed on the opposite side of the circle inside the triangle. 5. Angles from the same arc theorem. This theorem states that any angle made at the edge of the circle by the same arc is always equal. So if arc AB forms angles ACB and ADB on the circumference like this, then angle ACB is equal to angle ADB. 6. Equal arcs subtend equal angles. This theorem states that in any circles, if length of arc is equal, then it subtend equal angles at the center. For example, if arc AB in one circle and arc CD in another equal-sized circle are the same length like this, then angle AOB is equal to angle COD. 7. Equal chords, equal angles theorem. This theorem states that if 2 chords in a circle or in congruent circles are equal in length, then they subtend equal angles at both the center and the circumference of the circle. For example, if chords AB and CD are both 6 units long, then this angle at the center from AB is equal to this angle from CD, and this angle at the edge from AB is also equal to the one from CD. 8. Cyclic quadrilateral theorem. This theorem states that when all 4 vertices of a quadrilateral lie on a circle, then the opposite angles of the quadrilateral add up to 180 degrees. So if A, B, C, D form a cyclic quadrilateral, then according to this theorem angle A plus angle C is equal to 180 degrees, and angle B plus angle D is also equal to 180 degrees. 9. Touching circles. Theorem. When 2 circles touch each other externally like this, the distance between their centers is equal to the sum of their radii. So if this circle has a radius of 5 units, and the other has a radius of 3 units, then the distance between their centers is 5 plus 3, which is 8 units. Similarly, when 2 circles touch each other internally like this, the distance between their centers is equal to the difference of their radii. So if one circle has a radius of 9 units, and the other has a radius of 4 units, then the distance between their centers is 9 minus 4, which is 5 units. 10. Center chord perpendicular theorem. This theorem states that when a perpendicular line drawn from the center of a circle to its chord, then this perpendicular line will divide the chord into 2 equal parts. That means if chord AB is 12 units long, and line OC is perpendicular drawn from the center to chord AB, then AC and CB are both 6 units. 11. Equal chords and center theorem. This theorem states that when chords of equal length are drawn in the circle, then there are always the same distance away from the center of the circle. That means if chords AB and CD are equal in length, then this distance from the center to chord AB is the same as this distance to chord CD. 12. Diameter bisects chord theorem. This theorem states that if a diameter of a circle is drawn to a chord and divides that chord into 2 equal parts, then the angle formed at the point where they intersect is always a right angle, that is, 90 degrees. In simple words, if a diameter cuts a chord exactly in half like this, then this angle formed here is always 90 degrees. 13. Tangent perpendicular theorem. This theorem states that when a radius is drawn from the center of circle touches a tangent circle at the point of contact, then it is always perpendicular to the radius. For example, here, if this is A as point of contact, then the angle between the radius OA and the tangent is always 90 degrees. 14. The tangents and external point theorem. This theorem states that when 2 tangents drawn from the same external point to a circle like this, then both tangents will be equal in length, and the line joining the external point to the center like this also bisects the angle between the tangents. For example here, tangent PA is equal to tangent PB, and angle OPA is equal to angle OPB. 15. 2 secant segments theorem. This theorem states that when 2 secant lines are drawn from the same external point to a circle, then the product of the full length and the external part of one secant is equal to the product of the full length and external part of the other. For example here, secant AP cuts the circle at points B and C like this, and secant AQ cuts the circle at points D and E like this. Then product of AP times BP is equal to product of AQ times DQ. 16. Tangent secant theorem. This theorem states that when a tangent and a secant are drawn from the same external point to a circle, then the square of the length of the tangent is equal to the product of the full length of the secant and its external part. Example, suppose a tangent from point P to the circle touches the circle at point T. From the same point P, a secant passes through the circle, intersecting it at points A and B. Then according to this theorem, tangent squared is equal to external secant PA times full length secant PB. 17. Intersecting chords theorem. This theorem states that when 2 chords intersect inside the circle like this, then the product of the 2 parts of one chord is equal to the product of the 2 parts of the other chord. For example, if chords AB and CD intersect at point E inside the circle, then AE multiplied by EB is equal to CE multiplied by ED. With that, we wraps up all the important circle theorems, each one with a simple explanation and example. Now that you've got a solid grip on the concepts, I have one bonus challenge just for you to test your understanding. If 2 angles in a cyclic quadrilateral are 55 and 45 degrees, What will be the value of the opposite angle? Think it through and drop your answer in the comments below. Let's see who can figure it out. If you found this explanation helpful and learned something new, don't forget to hit that like button, share it with a friend, and subscribe for more mind-bending math puzzles. And if you'd like to support the channel even more, do consider joining our membership to help us keep making great content. Thanks for watching, and I'll see you in the next video.